Hello everyone, welcome on our YouTube channel. In this video lecture, we are going to learn some concepts of the science. Physics made easy quota help you to learn more about the science. So we are going to understand about the work that in our daily life we use the word work more frequently. A student sitting on a chair learning his lesson usually say, please don't disturb me, I am doing work. But you will be surprised that in terms of physics the student is not doing any work. So we are going to understand about the chapter work, power and energy in terms of the science. So in this video lecture we are going to learn these topics. Please have a look at these topics. In our daily life, work is said to describe any physical or mental activity. For example, a person who pushes a car but fail to push it is also supposed to perform work. Similarly, a student is considered to do work by learning his lesson. But in science, work is said to be done when a force applied on a body displaces the body through a certain distance in the direction of applied force. So the expression for the work done is W is equal to Fs. So you can clearly observe the diagram. Here in the diagram, an object is displaced by the distance x from one position to another position. Force is applied at a certain angle, that is theta is the angle between the force and the displacement. You can see that the component of the force which is along the direction of the displacement, that is a F cos theta. So work done is Fs cos theta. Cos theta means dot product of the vector. So work done can be expressed as F vector dot S vector. The units SI unit is joule for the work done and the CGS unit is erg. We can convert the joule into erg, that is 1 joule is equal to 10 raised to power 7 erg. Nature of work done. It is of the three types. First is a positive work done. If the angle between the force and the displacement is acute or less than 90 degree, then the work is said to be positive. Positive work means that external force helps in the motion of the body and it is along the direction of the displacement. Like for example, when a body falls freely under the action of the gravity, then the work done by gravity is positive, as the angle between the force and the displacement is 0 degree because the displacement and the gravitational force are acting along the same direction. So when theta is equal to 0, the work means it is a positive work done. For the negative work done, if the angle is obtuse, then the work is said to be negative. It signifies that the direction of the force is such that it opposes the motion of the body. For example, the frictional force, it is the opposing force and it opposes the motion, so the work done in this case is negative. And the frictional force and the applied force are acting on different directions at a same point, so the angle theta is 180 degree. When the theta is 180 degree, then the force does maximum negative work. For the zero work done, that is for the example of the circular motion, the work done by centripetal force is 0. Or another example, when a coolie travels on a horizontal platform with the load on his head, then the work done against gravity by the coolie is 0. So it means that when the angle between the force and the displacement is 90 degree, then the work is said to be 0. It means that there is no displacement or no force acting on the body, then work is also said to be 0 work done. So this chart shows the example. So for the positive work done, the force and the displacement is in the same direction. For a negative work done, force and displacement acting in the opposite direction. And for the zero work, either force is at 0 or the displacement is 0. Suppose there is a variable force acting on an object and which led to the displacement of the object. So the work done by the variable force is given by the expression dw is equal to F vector dot ds vector. Why we take here the ds vector? Because we are taking for the very small displacement when a variable force is acting on the object. To find out the total displacement, like the object is displaced from the point A to B under the variable force, then the total work done can be find out by taking the integral from A to B. We can also write the expression of the work done in terms of the rectangular components. Resolve the force into its rectangular component, similarly the displacement into the rectangular component. Then we can find the work done for the variable force by taking the integral, and the final answer we get the integral in the different axes like WAB. First of all, we write what is the amount of work done is in the x-axis, then what is the amount of work done along the y direction, and what is the amount of work done along the z direction. We must remember that there is no term like the instantaneous work. Work is defined for an interval or displacement. For a particular displacement, work is independent of the time, and the effect of work is change in the kinetic energy and the potential energy of the object. For the case of the numericals, we can also calculate the work from the force displacement graph. So here is a force displacement graph, and the force is a variable force. So we take the graph, and the graph varies from the point x1 to the x2. Then we consider the small strip to calculate firstly the small amount of the work done. Then we can find the integral to calculate the complete work done from the interval x1 to x2. So the work done from the small displacement dw is equal to f into dx, and f into dx also represent the area of the strip which having the length dx. And to calculate the total work done within the interval x1 to x2, we take the integral up from the x1 to x2 as the limits, and f dx is the area. So we can find the area under the curve, and the area under the curve x1 and x2 give us the work done. There are the two types of the forces. One is a conservative force, another one is a non-conservative force. Conservative forces are those if the work done by the force on a particle moving between 2 points does not depend upon the path taken by the particle, it just depends upon the final position and the initial position. For example, gravitational force. Gravitational force only depend upon the positions, it never depend upon the path, as the path can be changed with the other factors because of the air resistance, but at last the object is fall under the effect of the gravity. And the non-conservative force, if a work done by a force in moving a body from one position to the another depend upon the path. For example, friction force. Friction force always depend upon the path and the nature of the path. Energy always deal with the work. If there is energy, there is a work, or vice versa. We can't talk about the one topic and ignore the another topic. Both are similar in their meaning. So energy is actually the capacity for doing work. If we have energy, then we are able to do work, and the work can be performed only because of the energy. Work is a scalar quantity, so energy is also a scalar quantity. Its SI unit is similar as the work, that is a joule, and there are some other units which help at a commercial level and also for the numerical purposes for the conversion of the units from one form to the another. Please have a look at all these units. Energy has a very important relationship with the mass, that is called as a mass energy relation given by the Einstein, called as the Einstein mass energy equivalence principle, which state that mass and energy are interconvertible, that is they can be changed into each other. So the expression is E is equal to mc square. Here c is the speed of light. There are the various form of energy. Mechanical energy means when there is some work is going on, either as a stored form or when the object is moving. So that is, it is of the two types, or it is the sum of the kinetic energy and potential energy. Second form, chemical energy, magnetic energy, electrical energy, nuclear energy. Then we have the sound energy, light energy, heat energy. All these are the various form of energy. And most important thing, energy can be converted from one form to another for through various devices. There is neither the new creation or the destruction of the energy. Energy simply convert one form to the another.